So today's section is called Completing the Square, and this process is going to involve the perfect square trinomial pattern that we did last week when we were factoring, okay? So we're going to solve quadratic equations using this method that's called completing the square. We're also going to use the square root property, and this is just going to add to the ways that we can solve quadratic equations. We already have solved quadratic equations several ways. Can you guys think about the ways that we solved them last week? How did we find solutions to quadratic equations? Remember the directions said like find the roots or find the zeros? That was solving. So how did we do that? Come on, what were we working on last week, guys? What did we do over and over and over again? Factoring, okay, so we solved by factoring. That was a big one. And then the other way is we use the graph. Remember we went to the tables? Okay, we found the x-intercepts because x-intercepts and zeros, those are the same. Okay, and they're also called roots. They're also solutions of your quadratic equation. Now, do you guys remember how many solutions we normally had? 2. And that's because of the x squared. Okay, there should be 2 solutions. The only time there were 1 is when it happened more than once. Do you guys remember what that looks like on the graph? Do you guys remember what that looks like on the graph when the same solution happens twice? Yeah.
Then the roots are the vertex.
When
the vertex is on the x-axis?
Yes, when the vertex is on the x-axis. Great. Okay, so when the vertex is on the x-axis, it's a multiplicity. It happens more than once. Great. Okay, so the first thing we're going to do today is solving using the square root property. So our goal is to get the x squared term by itself. And once you do that, you can take the square root of each side. Okay? Now, when you take the square root, you have to remember to put the plus or minus in front. And let's talk about why that is. You don't have to write this one down, just pay attention. So we're just going to do a simple example. If you have x squared equals 4, right, we take the square root to solve, and then we have to put plus or minus 2. The reason why is because 2 squared equals 4. That would satisfy the equation, but negative 2 squared also equals 4. So we have to make sure we include both of those. All right, that's why you have to have the plus or minus when you are solving. All right, do you guys need more time for this, or are we ready to do the first example? We're ready? Okay, so the directions here just say solve the equation. So we are just going to be solving for x. So I'm going to give you the equation, and the first thing that you're going to do is take the proper steps to get the x squared term by itself, okay? All right, let's rock and roll. So we have 4x squared minus 20 equals 5. All right, so Cooper, what do you think in the first step is going to be? Okay, so this is going to be a little bit different than the factoring. If we were factoring, that is what we want to do because we would have everything equal to 0. Now what we want to do is get x squared by itself. So what should I do to get x squared by itself? Yep, add 20 to both sides. Good. So that will give me 4x squared equals 25. Okay, Ashay, what do I do next? So I'm trying to get x squared by itself. Yep, by?
4.
Yep. So now we're going to divide both sides by 4. and we're going to leave it as a fraction, okay? This fraction is actually very special. But we're not going to be dealing with decimals. We are just going to be working with fractions. All right? And then, Emmy, if I want x, what do I do to both sides? How do I undo the power of 2? You can come in here and share too. Okay, so we're going to take the square root, and remember that what the square root does is the inverse operation of x squared. So when you take the square root, it undoes that power of 2. The reason why is so that we can get x. Now, this part you guys may or may not remember. When you take the square root of a fraction, because it is division, you can split this up into the square root of the top over the square root of the bottom, which works out really nicely for this one because 25 and 4 are both what? Perfect squares. Okay, so if they're both perfect squares, then we can just take the square root of the top. We're going to keep that plus or minus over the square root of the bottom, which would be 2. So your final answer would be x equals plus or minus 5 over 2. And you can write your answer just like that. Just keep in mind that that does represent 2 different solutions. Okay, 5 over 2 would satisfy, and so would negative 5 over 2. You can always plug them back in to see if they make the equation true. All right, so I want you to do B on your own, and we will see how that goes. At least do the first few steps. Alright, and then once you get to your square root, we are going to be writing those in simplest radical form. So that might be something that you remember from geometry. I see some people making their factor trees. Did you guys learn the factor trees in geometry or earlier? For square roots? I'm just curious. In geometry. Okay. I wasn't sure if it was earlier. Okay, so Brianna, will you tell me what you do first for B? Good. So we're going to subtract 11 from each side, so you have 4x squared equals 48. Okay, and then Ava, what do we do next?
I divided 4 from each side.
Good. X squared is going to equal 12. All right, and then Emmy, what do I do when I get here? Square root both sides. Don't forget the plus or minus. Now we are going to write this in simplest radical form. Okay, we're always going to do that. We're always going to write this in simplest radical form. Okay, your answer should not be a decimal. All right, so there's 2 ways you can think about this. One way is you just find the biggest perfect square that goes into the number. So your perfect squares that you're checking, right, are 4, 9, 16, 25. How am I generating these numbers? It's not just that I have them memorized. How can you generate them? Where do they come from? Yeah, 2 times 2, 3 times 3, right? 2 squared, 3 squared, 4 squared, 5 squared. So you can use that list to help you, and you can go down the list and find the biggest one. Okay, so for 12, does 4 go into 12 evenly? Yep, so I can rewrite this as multiplication. So the square root of 12 is the same thing as saying the square root of 4 times the square root of 3. Because just like we can break up division, the fractions with division, we can separate this with multiplication. So anything that's a perfect square wants to come out. So the square root of 4 is going to simplify to what? 2. So this is plus or minus 2 root 3. Okay, that is going to be your final answer. And then some people also do factor trees. Oh, I also wanted to point out, why didn't 1 is a perfect square? Why didn't I start with 1? 1 times 1. Yeah, exactly. 1 times 12 would just leave you back where you started, right? You could always pull out the 1. All right, so you can also do the factor tree method, which is you start with 12 and you break it down into the lowest factors, okay, so the prime. So you could do 2 times 6, 6 is 2 times 3. Anytime there's 2 of them, they come on the outside. So if I have 2 2s, the 2 comes on the outside. 3 is the only thing I have left, so you could think of it that way as well. Okay? I don't care how you do it, we just need the correct simplification. Okay, so do what works for you. All right. For C and D, these are going to be a little bit different. Okay, for C and D, we are going to factor the side of the equation that is a perfect square trinomial. And that will be obvious. Okay, it'll be obvious which side is a perfect square trinomial. Okay, and then once we've done this, you guys will be able to recognize it. Okay, so when you see that you have a perfect square trinomial, you are going to factor using those rules that we did last week. Okay, so the first one, C, is x squared plus 8x plus 16 equals 49. Okay, so I want you to factor using the perfect square trinomial pattern that we talked about last week. So when you're factoring the perfect square trinomial, okay, first of all, I said it would be apparent which side is the trinomial. Is that apparent? Yes, which side? The left side, right? The other side only has one number, so it can't be a trinomial, right? Okay, so x squared plus 8x plus 16. So when you're factoring, you're asking yourself what multiplies to 16 and what adds to 8. So you guys can set up your parentheses just like we were doing with the factoring. Right? X times x, what multiplies to 16 but adds to 8, positive 4 and positive 4. And then do you remember how we write that as a perfect square trinomial pattern? What? Oh, just not along. Okay. X plus 4 squared equals 49. Okay, thumbs up if you're feeling confident with that part. You used a couple. Okay. So remember from last week, we have these special patterns. But with factoring, it's always what multiplies to the last number, what adds to the middle number. So you can always start with that. Then when you see that these are the same, x plus 4 and x plus 4, if they're the same, they're a power of 2. right? Just like x times x will be x to the power of 2. So from here, you have that square. The only way to undo a square, or a power of 2, is to do what to it? Square root. Okay, so we're going to take the square root of both sides. I just write that out again so you get, when you're looking back at your notes, you can see, oh, first I did the factoring, okay, then I did this. Okay, so you're going to factor, take the square root. So the square root undoes the power of 2. So then, Aiden, what am I left with here?
X plus 4.
Good. All right. Sorry. And then, Dane, what do I get on this side, on the right side?
I don't know.
Okay, so all we're doing is taking the square root of 49,
Oh,
right?
wait, this is 7.
You're very close. Ashley's like, don't call me. I don't know the right answer, but it's not 7. Brianna, you know? Or you know? What is it? Tell them. Yes, plus or minus 7.
Oh.
Yeah. So remember, you do have to put the plus or minus. I made a big deal of that because guess what people forget to do on testing quizzes? They forget to put in that plus or minus. Okay, so make sure that you do have the plus or minus. Another thing you can do to check yourself is, hey, you should have 2 answers, right? So the plus or minus is what generates your 2 answers. Now, if I'm getting x by itself, I'm going to subtract 4 from both sides. When I do that, these are like terms, so I can combine them. What I'm doing is 7 minus 4, but I'm also doing negative 7 minus 4. So I'm just calculating those two, okay? So 7 minus 4 is 3, negative 7 minus 4 is negative 11. So my final answer is x equals 3 or negative 11. And that is my final answer. All right, you guys ready to try this on your own? Yes, we can't wait. Great, because I got one for you. So x squared minus 12x plus 36 equals 28. So I want you to start this the same way. This one is a little bit different because you are going to have to simplify a radical using what we just talked about. Remember, for these, you are going to have the perfect square trinomials. All right, so the first thing we're going to do is we're going to factor. So it looks like a couple of us are still having a little bit trouble with the factoring. So when you have a trinomial with the x squared as the coefficient, okay, your first thing is splitting it up into x and x. So that should be pretty immediate with one like this. Now remember, I told you that they are perfect square trinomials for this. You are going to be using the square root property, so yes, they should be perfect square trinomials, which means they both have to be the same. But even if I didn't tell you that, if you are factoring, remember, you're looking for two values that multiply to 36, but add to negative 12. So that's just going to be what and what? 6, right? And then because this is a negative, make sure they're both minus. So it's not going to be plus every time. It depends on that middle number. So then I can rewrite it as x minus 6 squared. And then once you're there, you can take the square root. Okay, so then I have x minus 6 equals plus or minus the square root of 28. So you can think of this a couple different ways. You can think of it, what's the biggest perfect square that goes into 28? Or you can do the factoring. What is the biggest perfect square that goes into 28? 4. So I can rewrite this as the square root of 4 times the square root of 7. I will always write the perfect square first because I know that's the one I'm simplifying. So this will be plus or minus 2 root 7. If you are using your factor tree, I will show you how to do that as well. So with 28, you split it up into 2 and 14. That becomes 2 and 7. You can't break them down anymore. So once there's a pair, that goes on the outside. And then 7's the only thing that's left, so 2 root 7. Okay? Now this one, because you have the radical, we are not going to just add these together. What we're going to do is we're going to add 6 to both sides. And our final answer is going to be written as x equals 6 plus or minus 2 root 7. Okay, so if they're both numbers that do not have a radical, then you can simplify them. If it does have a radical, you will keep them just like this. This is the simplified form. So notice that none of our answers today are decimals, so none of your answers on your homework should be decimals. Okay, this is the correct way to write it. All right, for the next thing, we are completing the square for each expression, and we're going to be writing the resulting expression as a binomial squared. So we have to complete the square, and then we're going to write the resulting expression as a binomial squared. Really, the binomial squared is just another way to say that we are writing this in factored form. And when you are completing a square, it is just like the perfect square trinomial. Okay, so we're going to look at a few things with that to help us with A, B, and C. Alright, so basically what you are given, see how this is x squared minus 14x? You have to find that last number. So this is x squared plus 8x plus 16. How could I get from 8 to 16? Well, aren't you guys thinking that you'd multiply it by 2? Okay, but then let's look at this one. You have negative 12 to 36. I can't just multiply that by 2, right? So there is a pattern that you can use to find what completes the square. And it has to do with this number here. See how this is x plus 4? How is 4 related to 8? Okay, 4 times 2 is 8, right? Okay, how is negative 6 related to 12? Okay, negative 6 times 2. So, is it fair to say that the number that goes here is always half of this value? Half of 8 is 4, half of negative 12 is 6. What value is this in the equation? What do we call that? The variable. The b. So what you can do is you can take half of the b value, and then how would I get from 4 to 16? What could I do to 4 to get to 16? Square it, okay? What about this one? What can I do negative 6 to get to 36? Square it, right? So basically what we did is well, not basically, it is what we did. We took half of the b value. So b divided by 2, we take half of it, and then we square it. We take half of it, half of the b value, and then we square it. So anytime you are completing the square, you are going to use that. b over 2 squared. And that just comes from looking at the pattern, but now we have a nice little equation, a formula that we can use. All right, so for the first one, I'm just going to look at my b value, negative 14. Okay, so if I do negative 14 divided by 2 and then square it, half of negative 14 is negative 7. Negative 7 squared is 49. Okay, so when it says to complete the square, what I want you to write out is the trinomial. So x squared minus 14x plus 49. Okay, and then from there, the binomial squared is just the factored form. So what multiplies to 49 but adds to 14? 7, negative 7. Okay, so this is going to be your final answer. So we completed the square, the trinomial, that's going to be your factored form. Alright, and then go ahead and try that with B and C. Again, no decimals, so if it is not a whole number, you're going to leave it as a fraction. And then make sure you write your answer as a trinomial and then as a binomial square. Make sure that when you're factoring, that your sign matches what term. Your sign should match what term. Tell me. It's the B term, right? So if it's negative 14, you should have a minus in there. Alright, let's see how we did on part B. Okay, so we take half of 6 and then square it. So half of 6 is 3. 3 squared is 9. Okay, so x squared plus 6x plus 9. Then when we're writing this in binomial form, do you guys notice another pattern here when you factor it? Where else do we see the 3? Isn't this just half of your b value? Half of 6 is 3. Half of negative 14 is negative 7. So that may make this last one a little bit easier, right? Because if we do half of negative 7, that would be a decimal, so we're going to keep it. So when you square a fraction, you square the top and you square the bottom. So negative 7 squared is 49. 2 squared is 4. So you have x squared minus 7x plus 49 over 4. Okay, cut it in half, square it. Okay, then from there, like I said, when you're writing this as a binomial, you always have your x here. Now what goes here is half of that b value. Well, didn't I already write that when I did this part? Yep. So this is x minus 7 over 2. Okay, you can also check it, right? 7 over 2 times 7 over 2. 7 times 7 is the 49. 2 times 2 is the 4. And then if you were to add two of these together, it would be negative 14 over 2, which is going to reduce to negative 7. You would just add them together, adding fractions. Do we remember the rules of adding fractions? What do you have to add fractions? Common denominator. And then you add the numerators together, but the denominator stays the same. Okay, we are going to have to add a fraction and the whole number on the back, so keep that in mind, okay?